Okay, so today we're going to talk about solubility rules, and one of the things you need to have out, you need to have your star chart that has these solubilities. It should be on the back of your periodic table. Alright, so you need to understand how to use this chart. If you look at this chart, this is going to tell you the solubility of common ionic compounds in water. So, this first part, be sure that you pay attention to this, okay? These compounds are soluble, okay? So everything over here is going to dissolve in water. That's what soluble means, okay? Well, in this case, we're going to talk about water. It means that it's going to dissolve in water. Now, on this part of it, so it says soluble compounds, and then over here it says your common exceptions. So, this is acetate, and you can see that there are no exceptions. This is ammonia, no exceptions. This is nitrate, no exceptions. So what this means, whatever is next to nitrate, so this is the anion, remember, because it's negative, whatever cation, which is typically a metal, is next to it. So if it's NaNO3, Ca, NO3, whatever it is, all of it is always going to be soluble, which means it's going to dissolve. Okay? When we get down to chlorine, bromine, iodine, we're going to look over here. These compounds, if you get, and these are the exceptions, okay, so everything with bromine is going to be soluble except silver, lead, and mercury. Everything with chlorine is going to be soluble except for silver, lead, and mercury. And everything with iodine except for these. So do you see that there's a common trend? When we get over here to sulfate, everything that's with sulfate is going to be soluble except for strontium, barium, lead, and silver. So typically anything that bonds with lead and silver, you're going to have some insolubility issues. Okay. Now we're going to look down here at the bottom part of this chart. So the bottom part of this chart says all of these compounds are insoluble, which means these will not dissolve unless they're with something over here. Okay. And what this says is compounds with ammonia and alkali metal cations. Alkali metal cations means group 1. Okay? And you guys all know this. Anything in group 1 with these compounds over here will dissolve. So, your example of that is going to be, let me give you an example here. So if I have sodium, okay, and it's a group 1 metal, and it's with, in this case, carbonate. Okay. This is going to be a 2 over here. We're going to say that this is aqueous, which means it's soluble. Okay. Let's say I add to this solution well, we'll just stop there for right now. Okay. Another example here is then if I have ammonia with your phosphate, that's going to be soluble. Any of your group 1. Here we have hydroxide. All of the compounds, so if it's with NH4 or if it's with an alkali metal, right? So in your group 1s or calcium, strontium, barium, they're all going to be soluble. Okay? So let's go through a couple examples so you can see how this works. Let's say I give you the equation. You've got AgNO3 plus NaCl. So the first thing we need to do is we need to look at these two compounds, okay? Silver, nitrate. So let's look for this right here, the nitrates. If I go to my chart, I'm going to see my nitrate here. It says that this is soluble and there are no exceptions. So silver nitrate is going to be soluble and we write AQ. Now, AQ means aqueous, which means dissolves in water. Okay. Let's go here to chlorine. We see chlorine. We see compounds with silver, lead, and mercury. They are not soluble. So, sodium is not one of these over here, which means sodium chloride is soluble. So what's going to happen is I put a solution of this, it's going to be a clear solution. I take a solution of this, it's going to be clear. I add these two clear solutions together. What's going to happen over here? Well, this is a double replacement reaction, which means the cation is going to go with the anion, and the anion is going to go with this cation. So basically they're going to switch partners. And I'm going to get NaNO3 plus AgCl. So now we need to come back here and we need to check these two and find out if any of these are going to be soluble and which one's going to be a solid. So if I look at this example, okay, we're going to look at your nitrates. We see nitrate, we see that there are no exceptions, so this is going to be aqueous, which means it dissolves. Now, we get AgCl. So let's look over here at Cl. This says chlorine. Anything with chlorine is going to be soluble unless it's silver, lead, or mercury. Well, we have silver right here, so that means this is going to be a solid. And what we say is this forms a precipitate. Okay, and all that means is that you pour these two solutions together, put a little bit of one in here, a little bit of the other, and once they mix, what you see down here at the bottom is you see some sort of solid. Okay, and you guys will see we'll do a couple of reactions like this in class. We'll do a couple of demonstrations, or you guys will get to do a lab one way or another. All right, let's look at a couple of other examples, and then that should be it for this part of it. All right, so I've got PbNO3, 2, so it's lead nitrate, and I'm going to add to this potassium iodide. So we're going to predict the products, okay? First thing I want to do, I want to look and see if lead nitrate is soluble and if potassium iodide is soluble. So I'm going to come over here, and I'm going to look at nitrate. I see that there are no exceptions, so I know that this one is aqueous. Now I'm going to look at my iodide. Iodide says all compounds are going to be soluble unless it's silver, lead, mercury. Well, this is with potassium, so this means it is aqueous. Okay? Over here, we've got, remember this is a double displacement reaction, so my lead is going to go with my iodine. And remember, this is a plus, this is a minus, this is a plus, this is a minus. The plus is going to go with the minus. The plus is going to go with the minus. We never put two pluses, we never put two minuses together. Okay? So double displacement reaction, so we get Pb. Remember, this is a 2 plus, and we have iodine, which is a 1 minus, so we got to cross these, and you're going to get PbI2 plus, in this case, potassium and nitrogen. Potassium is a 1 plus, sorry, nitrate is a 1 minus. When we cross those, you get KNO3. So let's go back to our chart. Look at your nitrates. We know that all nitrates are soluble. So this is going to be aqueous, and then we go over here and we get PbI2. So we'll look at I, and we know that this is, all of these are soluble unless it's silver, lead, or mercury. In this case it's lead, so this is going to be my solid. Now here's what happens. This is actually what's happening in the beaker. Okay, so we put in this solution. You're going to take your lead nitrate and you're taking your potassium iodide. Both of these are a solution, okay? We're mixing them in here together. So we've got Pb2 plus, we've got NO3. So let's say we're putting the lead nitrate in here first. So this is a 1 minus, right? So we have a whole bunch of these. NO3, 1 minus, we got a Pb2 plus over here, we got another Pb2 plus, another nitrate. Okay, so that's what's in here first. Now we're going to add a solution, okay, so everything's dissolved in water, of potassium iodide. When we add the potassium iodide in here, okay, so now we've got K plus in the solution and we've got I minus. K plus, I minus. So what happens is every time these two come in contact with each other, they're going to form a compound. And it's not just one, it's got to be two of them, right? Because this has a 1 minus and a 1 minus charge, right? So I've got a 1 minus here, I've got a 1 minus here. So these are going to form a compound, so that your solution ends up looking like so this is going to be my solid here at the bottom, and this is a whole bunch of PbI2. Now the question is, what's left up here? This is everything that's still soluble, so it's still dissolved in water, so you can't see it. So this is your K plus and your NO3 1 minus. These ions are still floating around in the solution. Okay, so that's what's actually going on in the solution. So your solid forms from these come out of the solid, and we're left with these ions in the solution. Okay, all right. let's go through one more example. So let's say we have Na2SO4 plus let's go with SrCl2, so strontium chloride. Okay. So again, we're going to look at our rules over here. We see that sulfates, all sulfates are soluble except strontium, barium, lead, and mercury. So in this case, we're going to get this is going to be aqueous because this is with sodium. And then over here we look at all chlorines, and we have silver, lead, and mercury. These are the ones that are insoluble, so that means that strontium chloride is soluble. So let's predict our products. We are going to have strontium, which is a 2+, sulfate, which is a 2-, so we get 2 and 2, so we just leave it as it is, plus Na, which is a 1+, and Cl, which is a 1-. Those are going to cross, and we get NaCl. Now here's the question. We go back here and we look. We know that all chlorines are soluble except for silver, lead, and mercury, so sodium chloride is aqueous. Now, all of your sulfates are soluble except for, in here we see strontium. So this is going to be a solid. What happens if you have something like NaCl plus, let's say CaOH2? Okay? So we go down here and we look. We know that NaCl, so we know that all chlorines are going to be soluble except for these. So sodium chloride is aqueous. And over here we've got calcium hydroxide. So we're going to look here at hydroxides. And remember, all of these are insoluble, which means they will not dissolve, except for those with calcium, strontium, barium, ammonia, or your alkali metals. So this means that calcium hydroxide is going to dissolve, so this would be aqueous. Now when this reaction occurs, we get CaCl2 plus NaOH. So chlorine, so calcium chloride, calcium is not one of these, so this is going to be aqueous. And we have sodium hydroxide, so we're going to go down here to OH. There's your hydroxide. And sodium is an alkali metal because it's in group 1 on your periodic table, so that means this is going to be soluble. So in this case, we did not form a precipitate. Okay? And that will conclude your solubility lesson.